In addition to counting on, first graders should be starting to use level 3 arithmetic strategies as well. Work on these strategies not only supports children's work with arithmetic fluency, but it also deepens children's number sense and their understanding of the properties of addition. As you're actively supporting children's development of counting on as a strategy, you can simultaneously be working on the foundational prerequisites for their transition to level 3 methods. In this lesson, we're going to look at level 3 methods with a specific eye to naming the underlying skill sets that children need to have in place so they can develop this type of strategic thinking. These are the level 3 methods that are specifically named in Standard 6 in the Operations and Algebraic Thinking domain. We're going to take a look at each of them one by one, see an example, but particularly the focus is on pulling out that underlying skill set that's needed. So first we're going to examine the most versatile and useful strategy of them all, make 10. To illustrate how this strategy can be used, we're going to take 8 plus 5 as an example. In this approach, my goal is to intentionally choose to convert one of the addends into a 10. That's why we call it the make 10 strategy. I do get to choose, however, which addend I want to convert. And in this case, I'm going to show two different ways to go about it. Some children may choose to convert the 8 into a 10 because it's closer to 10. Other people really like that 5 plus 5 fact, and so they'll want to pull a 5 out of the 8 to give to the other 5 to make 10. So the way we convert it then is decomposing the other addend in such a way that the quantity that we need to make 10 is available. As a result of that, it's going to have a leftover. Okay, so if we look at the example on the left, I am breaking up the 5 into a 2 and a 3, giving the 2 to 8. That makes a 10, and then I still have the 3 left over from the 5. So I have converted 8 plus 5 into 10 plus 3 and stated that those two are equivalent, the two equivalent facts. But 10 plus 3 is easy enough for me to solve mentally. 8 plus 5 may not be. So now we're going to take a look at each of the steps that were involved in that strategy that I just showed you so that we can think about what the prerequisite skills were. The very first thing that I needed to do was to use what I know about sums of 10 so I could figure out how to decompose the other addend. So the sums of 10 were to be learned in kindergarten, however they may not be real fluent yet. Children were to have worked with decomposing 10 into partner numbers. So that's an experience that they already have, but it wasn't listed in the Common Core as something that they had to be fluent at yet. And we do need them to be pretty fluent. It isn't enough to just be able to construct these facts on the go. The children need to have enough cognitive load available to coordinate all of this strategic thinking. And so it's going to be tough if their sums of 10 are still not very fluent. So we want the sums of 10 to be readily available so that they don't require a lot of mental processing. So in the teaching resources section, I'll put a couple of games that you can use to help children build their sums of 10, and also a couple of other ideas. Just as a quick example, though, one thing I do is just a warm-up is to roll a large die on the floor when we're in a group meeting in the morning. I'll roll it several times. It will generate a number, and we'll quickly state as fast as we can what the complement is to that number. So if I roll a 6, well, I'll say 4, and if I roll a 2, well, I'll say 8, like that. That's something you can do very quickly. We're talking 15 to 30 seconds, several of them, just as fast as you can, and it's a nice review to do on a daily basis. Once I make a 10 in step 1, I have to decide what other number resulted from that decomposition. So that means I have to have experience with decomposing numbers up to 10. And this is also a kindergarten standard, although again, realistically, children will need to continue to work on that skill in first grade to be able to do those decompositions more fluently. To foster level 3 methods, we need to ensure that the individual steps on their own can be accomplished with relative ease. If each individual step has pretty low cognitive load, then the child can spend their mental energies figuring out how to coordinate them You will be amazed, though, at how quickly your children can do this. It takes much longer, on average, for a child to explain how they thought about a problem than for them to produce the number. That's, of course, after they've learned how to put all these steps together and think them through. So level 3 methods initially take more time to develop than, say, rote memory. But once you have it, they're as fast as they would be if they had it rote memory, plus they have the number sense and the flexible strategic thinking that can then be applied to larger numbers. The last step involves children being so comfortable with the teen numbers that they can just quickly see the teen number that results with the 10 and leftover. So when I convert 8 plus 5 to 10 plus 3, we want them to be able to know instantly that's 13. Not to have to think 10 plus 3 is how much again? We don't want them to have to go 10, 11, 12, 13. Again, in kindergarten, they were already to have been working with teen numbers, and they were to have been working on how to decompose a teen number into 10 and 1s, as well as to take 10 and 1s and convert it into a teen number. Again, you'll need to see how your first graders are doing on this particular standard when they come into first grade. So what you see is that the level 3 methods rely on several kindergarten competencies, and these competencies were expressly placed at the kindergarten level to prepare first graders for that transition to level 3. Children should have already begun extensive opportunities to decompose numbers up to 10 into 2 addends, and in addition, their work with understanding the place value of teen numbers is critical. As I said before, though, it isn't enough to assume when they arrive in your classroom that decomposing was developed in kindergarten. Your early work with children in first grade should provide a lot of opportunity to foster part-whole relations and decomposing of number. I've placed a document in the teaching resources for this lesson that has quite a few instructional ideas for fostering the idea of decomposing. Some of the ideas are briefly illustrated here, but they're described in more detail in that document. Another level 3 strategy involves leveraging a big idea of mathematics, and that is how addition and subtraction are related operations. The subtraction fluency of children lags behind their addition fluency. But if children understand how the two operations are related, they can often use their more advanced addition knowledge to support their subtraction. To do so, though, they really have to see the relationship. Number bonds are a useful representation that can help serve to make that relationship a little more obvious or visible to children. So the number bond for 16 minus 8 makes it clear that when you subtract 8 from 16, you're really searching for the other addend that you could combine with 8 to make 16. And if you can think of it in those terms, you can see, oh, 8 plus 8 is 16. Because very often children have that double fact very readily available before they are expected to have fluency with 16 minus 8. The whole idea then of this strategy is if I know the complementary addition fact, I could easily convert this subtraction problem into an addition problem. All right, using the prerequisite skill then here isn't really a skill, it's more of an understanding, and it's an understanding of the relationship between the two operations. So we've talked previously about how number bonds can be used. There's a general relationship. Then this is the way it looks. The middle one is how it looks when you have an addition problem, and the bottom one is how it looks when it's a subtraction problem. Missing addend problems are a useful way to begin to get kids to explore this idea. Also, having a lot of different number bonds that are produced in a variety of ways, including from their problem-solving work in the classroom, from their fluency work in the classroom. If they have some experience with number bonds, you can even do some classifying. How did we eventually find a solution? Did we add or subtract? Okay, let's put that number bond that ended up being an addition one into this addition column. They'll begin to notice that whenever you know both parts, but you're missing the whole, it was addition. When you were having a whole and one part, but other part was missing, it was a subtraction problem. And when they begin to understand the mathematical meanings of addition and subtraction as opposed to perceptual, that feels like a subtraction problem maybe, they will actually be more likely to use this skill where they can relate addition to subtraction. This particular standard about the relationship between addition and subtraction is standard 4 under the first grade operations in algebraic thinking. Decomposing a number leading to a 10 is another helpful strategy, and I've demonstrated it here with subtraction, although it can also be used with addition. I'm using it with 13 minus 5. This is a difficult fact for children. It requires crossing a decade. However, if they have really good number relationships, they can easily break it into 2 steps using 10 as a landmark number between 13 and 5. Again, we see that decomposing the 5 into a 3 and a 2 is helpful here because we can go from 13 minus 3, get to a 10 as a stopover, and then subtract the other 2 to get to 8. The second step is helpful, if we know those sums of 10. In addition to decomposing number, knowing the sums of 10, and understanding the relationship of addition and subtraction, there's one additional skill here as well, and that involves knowing where the numbers are in reference to landmark numbers. So if I go back here for just a minute, you can actually see that I have to kind of mentally know on a number path where 13 is in reference to 10 and where 8 is in reference to 10 in order to have figured out how to use this strategy. The mental number path allows me to navigate back and forth. Children should already have a good understanding of a number path, certainly very solid up through 5 even when they arrive in your classroom, but probably even to 10 for most children, and then that will need to be extended over the kindergarten, over the first grade year, so that they really have a very solid number line in their mind all the way up through 20. Any anchor fact that a child knows well could potentially be leveraged to determine nearby facts that are more difficult. For example, children can use a doubles plus 1 or a doubles minus 1 strategy to create equivalent but easier sums. If you take a look at the words and quotes, you can see some of the variability of what this sounds like when children are describing what they did as they used facts they know to come up with facts they don't know. To pull off this last category of level 3 methods, children need to know their anchor fact, which in the case we just saw was doubles, but could also be sums of 10, or even their facts that they come in with fluent to 5. And they also need to be able to count on 1 or 2, because this last category often works by taking a known fact and then going up or down 1. So it's combining, let's say, a doubles fact with the capacity to count on together that creates this new strategy. As you are actively fostering counting on, you can be working on the prerequisite skills to pave the way for that next transition on the horizon. This work is largely either a reinforcement of ideas that were already starting to be developed in kindergarten, or else they relate to Common Core concepts in the first grade curriculum as well. All of these prerequisite skills that you see here, which are summarized from this entire lesson, they represent foundational ideas in building number sense. So even if they weren't expressly helpful in developing level 3 methods, they would still be worth pursuing and developing in your learners for what they can do for their number sense. The primary purpose of this lesson was to explore prerequisite skills that are embedded in the Level 3 methods. Next week, we're going to extend our study of how to actively develop these methods in a